Hello everyone, welcome back to the channel. So today we are going to understand how to create the uh, application load balancer with the secure connection. We had we had a separate video where we had actually connected using the HTTP, which was the unsecure connection. Now we'll use the secure connection. Let's create the load balancer. And first, let me just create the target groups also. I have this one target group for ALB. I'll just create the target group for another target group, and your protocol would be 8080. I'll select admin in this case. Let me change stack. Look, uh, top is already admin is already created. Let me top. This is my shop instance. Okay. My target group is created. In case of uh, ALB, just one more thing that I wanted to show was the target group properties. This is target deregistration management. Basically, deregistration delay. Say suppose my instance is unhealthy and I want to terminate that instance. In that case, while deregistering, right, while before ALB deregisters it, right, so what will happen? Uh, say suppose I had already sent 10 requests to that particular instance. So it is currently processing it, right? It is going to return to the client. Otherwise, client, if I immediately terminate it, I can do that. If I mention zero here, it will immediately terminate. So as soon as it is unhealthy, it will not send back the response. But now, since we'll mention some delay, right, which is called as draining interval, or you could say connection draining or deregistration delay. In that case, uh, it will actually wait for that those milliseconds, and whatever response that it is going to get, it is going to send back to the client. But any new request won't be sent as soon as it is found to be unhealthy. So just understand this important concept of deregistration delay. So based on how much time your processes take, right, you can configure here. Then you have this load balancing algorithms, like whether it is round robin, least outstanding request, or weighted random. The round robin is basically sequentially. First EC1, EC2, EC3, then again EC1, EC2, EC3. In this sequence, it will keep on rotating. This is called as round robin. And then we have least outstanding request, basically any instance which has the bandwidth, right, which has the least outstanding request. That will be the ALB will be sending that request. And then weighted random is basically it will evenly distributed among the filter targets, evenly distribution. And then we have this option of stickiness. Here we can the load balancer can generate its own key, which is named as AWS ALB, or even application can send its own cookie, and we just need to mention the name of the cookie name. So in this way, it is going to bind a user session to a specific target. Say suppose particular user had sent a request to instance EC1. Okay. Now second time when it is sending again, and we want that session to actually continue in the CM instance. So this is called as affinity, session affinity or stickiness. So using this property, we can enable it. And then we have this option of cross zone load balancing. What happens with the cross zone load balancing? You actually divide the traffic evenly across availability. Otherwise, it is not evenly distributed across availability zones. It it will be unevenly distributed based on the number of instances that the availability zone has basically. These are the important attributes that you can set. Currently, I am not setting anything. I have kept it as default. Now let's create the application load balancer. When I create the application load balancer, my ALB is internet facing. I'll select the VPC. I'll select the availability zones here. We create a new security group. I think I can use the previous one. Well, be fine, I think. Then here I will use HTTPS, and uh, I'm not going to authenticate anyone, no rerouting action. I am just going to forward it to the target group. Okay, so here I forward it to the admin target group for now. Then we will change it in the rules section. Once we create this, then in the security policies, now from where do we get this SSL certificate, right? Here we have all these options from IAM, from ACM, or if you want to import your own certificate, you can paste your private key body, etc. But I'm going to use the AWS Certificate Manager. I have this certificate already created for me for this stvision.click domain, which I'm going to use. And then MTLS, I'm not going to enable it, not required for now. And then I'll just create the load balancer. Okay, now once this load balancer is getting created, we'll go to the rules. In the listeners, you can add a new rule. Here I'm going to add a condition path based value match plus API plus admin plus star. This is the condition. Again, I'm going to call this admin group. I don't want any stickiness for now. I will set the priority as 1. Add rule. I just created the rule now. I'll create another rule for the shop. I'll forward it to the shop group ALB. Just in case if you're finding this very fast, because I have already covered ALB hands-on separately in the other video, you can actually first refer that particular video, and once you understand that video, then you can actually come here for the SSL certificate. Now, as far as the default one is concerned, it will go to the admin group in case of default. Now we have added this rule. I'll just change this default one for now. This rule. Instead of forwarding to the this one, I'll forward a default text. Okay, that's it. Now once I do this, let's see if the ALB is ready. It's ready. It's great. Now once ALB is ready, just we will verify it is working fine or not. Oh, okay. Directly verify. I just need the Route 53 first. Let me do that. In Route 53, I go to my hosted zone. Okay, this is my hosted zone. Here I'll create a record, and I'll just mention alb.htvision.click. Here there will be my C name. Let me check the DNS of my ALB. Copy this DNS of my ALB and I'll paste this as value. And that's it. My record is created. What I can do is I can directly you need to mention any port number, as by default for security is 443, HTTPS it is 443. As you can see, it is working fine, and you can clearly see it is using HTTPS. So it's a secure connection. You are able to successfully do that, and plus we were able to do the termination part as well. If you look here in the HTTPS rules, we'll just look at the resource map that will give more clarity. Here we have this resource map. You can clearly see first it's an HTTPS connection between client and the load balancer, and then when it is forwarding to target group, it is sending as an HTTP. Here there is an SSL termination which happens between the load balancer. After the load balancer sends it, before load balancer sends it to the instance. So this was the information about how do you set up your load balancer with the secure connection. Thank you so much. Have a good day.